Hello, I apologize that I'm using the Smart Notebook Recorder again. The Screencastify is having a slight issue right now, not responding, so this is what we're going to have to go with. We are looking at the notes for Combined Like Terms 7-3 Part 1. This is the first day of Topic 7, and again, as I said in class, we're going to do things a little bit differently. We're not doing it directly in order as digit shows. You do not have this original problem on your paper. I just want to show this to you that we have this expression here, negative 5b plus 7a plus 3 minus 4c. And we're going to start talking about some vocabulary using this example, which is on your notes. I'm going to talk about here that I am looking at 4 separate terms. So what I have done is I've now gone through and put a box around each of those separate terms. What I'd like you to notice is that when I put a box around the term, I also boxed the sign that was in front of the number. So this is going to answer some of those questions about, is it a subtraction sign or is it a negative sign? Now, you cannot call a subtraction sign both at the same time. It's either one or the other. You need to make your decision of what you want to call it. So I would read this problem normally as negative 5b plus 7a plus 3 minus 4c. But now what I'm going to do is I'm actually going to take these terms and I'm going to move them around, but keep the sign that's in front of the number. So I'm now going to move this, and when I move this to the end, I now am going to read that as 7a plus 3 minus 4c minus 5b. Notice I did not say the positive sign that's in front of the 7, and I now said that this was a subtraction sign instead of a negative sign. So it's all, the sign is called what it is depending on where the location of it is. So what I'm just trying to show you is that eventually we're going to be rewriting our terms in like descending order. So I look at this and I see I have 3 different variables in 4 different terms. I also then have 3 different coefficients, and I have a constant. I'm going to put these in order alphabetically. So I've got 7a, then the negative 5b, then the negative 4c, and the positive 3. So if I was to rewrite this, it would say 7a minus 5b minus 4c plus 3. So it's just a little introduction to what we're going to be talking about. So on your notes, it states that quantities that you add to form an algebraic expression are the terms of the expression. So terms is one of your vocabulary words. The number factor of a term is the coefficient of the term. That is the one that is being multiplied to the variable. And a term without a variable is just considered a constant term because it's constantly being called whatever number we've decided. So they have given us our constant term as 2 here. You constantly call it a 2. You can't call it anything else. That's why it's called a constant. So they are showing you here that you have 3 separate terms. They're telling you what the coefficient is on the negative 5x, and it's negative 5. Notice the coefficient does not include the x. They are also stating that the coefficient on that y is technically a 1 because 1y, change that, 1y is the same thing as y. Normally we write it without the coefficient, but you might find it helpful to put that 1 there. And then again, the constant term. They also are reminding you that addition and subtraction signs separate the terms. So we're going to go ahead and look at example number 1, and we will fill in the first column together, and then I will have you go ahead and try the remaining 3 on your own. So what they're doing is they're giving us an expression, and they'd like us to identify the number of terms, the coefficients, and constants if there are any. If there are no constants, just write none. So I look at this and I say, okay, I've got 2 terms. I've got 12a and minus 3. So I've got 2 terms. The coefficient, again, is the number that is attached to the variable by multiplication, so that is my 12. And the constant, and this is where some of you might get this wrong, you might accidentally just say that it is 3. But because I am circling that negative sign and including it with a 3, it's actually a negative 3 now. Because if I was to rewrite this, I could rewrite this as negative 3 plus 12a now. So that subtraction sign becomes a negative when I look at these as being separate terms. So please pause the video and go ahead and do the remaining 3. Okay, please check your answers over. The ones that I'm just going to make sure that you were really careful on were y. It's actually -1. You want to make sure that you included that there, and that for these two, there were no constants. Go on again, pause the video, and maybe you'll redeem yourself with example number 2. Check your answers over. On your next page, we now have more vocabulary that says terms that have identical variable parts are called like terms. And I don't think that they give you a full definition of what like terms are. We'll give a little description on the side after I go through this chart. They are showing you that on the left, the like terms, and they're showing terms that are not like on the right. So I want you to notice that all of the like terms, it says they have identical variable parts. This one has an x and this one has an x. They are considered like terms only because of that x. It has nothing to do with the coefficients in front of them that says whether they're like terms or not. One is positive, one is negative. That's perfectly okay. It's just the x, just the variable we're looking at. Then x squared and x squared, they're identical variable parts because they are both x's being raised to the same power or exponent. Like terms again here, xy and xy, they both have an x and a y. If it happens to be written like this, they would still technically be like terms because multiplication is commutative and you can flip the order. 2 and -3 are also like terms. A lot of students forget about that. Those are constants, and constants, you've always been able to combine those together, so they are also like terms. So then what makes up not like terms is if the variables are not identical. So in this case, we've got an x and a y, and they're not the same. Then we've got an x squared and just an x. Because x squared is technically x times x, they are not identical parts. Same thing with xy and x. One has a y, one does not. They are not the same. And then on the last one, this is just a constant, and now the y is over there by itself. So you want to remember that they have this, like terms, have the same variables being raised to the same exponent. Again, it has nothing to do with the answers being positive or negative, the coefficients, excuse me. I am going to ask you to do the next 6 questions on your own. You're just going to say either yes or no if the terms are like. But I'd like you to add 2 more examples here. So 4 and -5, and then -2rs and 4sr. So please work on those. Pause the video. Okay, please check your answers over. What I have done for questions 2 and 5 is I've actually written out what those would look like when you have p to the second power. It's the same thing as pp. And then number 5, abc squared. The squaring is only on the c. It is not on any of the other letters, so it's 2abcc. And then when it says 2a squared, that's the same thing as 2aabc. And then the 2 that we added, they are both like terms. Again, 7, these are just constants. And on number 8, again, I told you that since multiplication is commutative, you can switch the order. So now we're going to talk about actually combining these. And it says, when combining like terms, add or subtract the coefficients and keep the variables the same. If the terms are like, you can combine them. If they are not like, you cannot. So we're going to go over these 4 together. So I just want to make sure that you're clear with me. So when I look at this, this is saying 9x plus 2x. That's literally x plus x plus x plus x plus x plus x. 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't write that all down, but that's literally 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. And then if I add 2 more x's, how many x's do I have altogether? I have 11x. So what some people like to do is they say that since x and x have like terms, they're going to take the 9 and the 2 and combine them together and then have the x on the outside. And that's still what gives you 11x. This step right here, people will show, some people don't show. For the next one, negative 3a plus 4a minus 10, they are all like terms. They all have an a on them, so I'm just going to add or subtract the coefficients. So I will start from left to right. I have negative 3 plus 4. Negative 3 plus 4 is 1a. Make sure your a looks like an a and not a 9. Then I'm going to bring down the minus 10a. I'm going to rewrite that as 1a plus negative 10a. And 1 plus negative 10 will give me negative 9a. So there are our integer rules. Again, you will be allowed to use a calculator for this topic, but again, you can't pick up your calculator and put in negative 3a plus 4a minus 10a and expect to get an answer. For the third one, negative 16cd plus 3cd, they do have like terms. So again, I'm just going to look at the coefficient in the front, the negative 16 and the 3, and I add them together, which will give me negative 13cd. You don't make it c squared, you don't make it d squared. It's just literally how many c's do you have, how many d's do you have. And 4x minus 5 plus 6x plus 7. Going back to what we did when I first started, I'm going to rearrange these so that the like terms are next to each other. It makes it easier. So when I rearrange them, I need to make sure that I'm careful and keep the sign in front of the number. So I'm going to have this as 4x. I'm going to leave that there. And when I bring the plus 6x down, I need to make sure that I bring that plus sign down with it. And then this is where you have two options. You can bring the minus 5 down first, or you can bring the plus 7 down first. I see that since 7 is the larger number, I'm going to bring the plus 7 down and then bring the minus 5. So 4x plus 10x is, I gave the answer away, 4x plus 6x will be 10x. And then this is a positive 7 right here, minus 5. A positive 7 minus 5 is going to give you a positive 2. So the plus sign is taking the place of the positive there. We are going to be doing a lot of practice with these. Here's yet another one, because they didn't show you any with exponents. I just want you to be clear that if you had 4x squared plus 3x squared, you literally are still only combining your coefficients. So I've got 4 plus 3, which is 7, and x squared stays x squared. Number 4 is asking for you to decide which ones have like terms, and then to go ahead and combine those like terms. Go ahead and give that one a shot. All right, so only the first one has like terms. I just rewrote it again, putting a negative 1 in front of the x, just to remind myself that it is not just going to end up being 3 5/10 x. I have to now actually combine negative 1 plus 3 5/10 to get 2 5/10 x. Number 5 is asking for you to decide which 3 expressions have like terms, and then again to go ahead and combine those like terms. Please work on those. Check your answers over. Now, some of you on the last one might be getting better at your integers, that you might not necessarily needed to change the 7xy minus 10xy to 7xy plus negative 10xy. I'm just showing you what you would do in that case. Okay, we're going to do the next 2 examples together, and then I will let you do number 8 on your own. These ones are very similar to the state review questions that we did that I said we were going to start to go over. This one says that the produce manager at the grocery store increases the price per pound of all the types of fruits by 3%. Let P be the original price per pound of a type of fruit. Use this expression for the new price per pound of a type of fruit. And then what they want us to do after that is to write an equivalent expression by combining like terms. So when I look at the expression P plus 3/100ths P, at first you might be saying, where did that 3/100ths come from? Well, I'm going back to the question where they talked about 3%. We know 3% as a decimal, not a fraction, is going to be 3/100ths. So what they are saying is that P represents the original price. So 1p, isn't 1 really the same thing as 100%? So it's 100% plus 3%, so it's 100% p, plus 3% of p. But because we don't like to put percent into our expressions, they've rewritten the percent as decimals. So now, how would I write an equivalent expression by combining like terms? Well, I would take 1 and add 3/100ths to it to get 1 and 3/100ths p. It's that simple, and it can also be that complicated. You need to make sure you understand what's happening. On number 7, this time they're talking about the bakery manager at the grocery store. He decides to have a 15% off sale, so we're not increasing the price. He's taking 15% off sale on all bread. Let B be the original price of a loaf of bread, and then use this expression for the new price of a loaf of bread. So they are now again taking 15% and rewriting it as 15/100ths. That's where the 15/100ths is coming from in our expression. Again, there is a 1 in place of that, in front of that B, so 1 minus 15/100ths is 85/100ths B. How you are used to seeing this is that if you had 100% as the original amount, we're taking 15% off, so we're taking it off, so we're subtracting, so we're actually paying 85% of the original. Go ahead and do number 8. Right? So I again am looking at this as 100% is the original price, 30% off is what we're saving, so 70% would be what we're paying, and so I just calculated again that 70% is the same thing as 7/10. So I'm stating that 70% of the original price is what you pay, and 70% equals 7/10. So yes, I agree with that statement. Thanks for watching. We'll see you guys tomorrow.